Welcome to section 2 of Python programming language. In this section, I'll be talking about classes and objects as well as lists in detail and go through more programming examples. Everything in Python is an object, like everything in R is a function. And at the lowest level, we have data definitions, data types, and functions. When I say everything in Python is an object, you'll see that besides being an object-oriented language, it's also a scripting language like R. But what happens is that you take anything, any variable, the moment you define a variable, it becomes an object. What we mean is that it carries a certain collection of functional properties with that object, whatever we define, starting with a variable, okay, starting with the data element. So you will see that with a lot more examples as I talk about those ideas. But before I talk about details on objects, I want to bring out the important definition, what is called classes, which is the blueprint for creating objects. What classes mean is the following. It is a logical grouping of data and functions that are behaviors of data elements that have some special interconnections among them. So classes are a collection, a logical grouping of data and functions, also called methods, that have some special interconnections among them. Again, classes can be thought of as blueprints for creating objects. Without well understood classes, we cannot really talk about object orientation. And objects are, when we say the blueprints, from blueprint you can take the images, and the images are the instantiations are called objects. So again, the copies of the blueprints called classes for a very specific application. That's what instantiation means. For very specific applications of a given set of data and behaviors are called objects. Is that clear, Venkat? As I said, classes have built-in data relationships, also called data models, among its members. I will summarize the notes from a beautifully written document on classes and objects in Python by somebody called Jeff Knapp, who has published that particular specific article about Python classes and object-oriented programming in this link. Okay, I will leave it to you to read lots of details there. Okay, but I will give you, in a sense, what we mean by a class versus an object. Okay, for example, in a CRM system, customer relationship management system, there is a natural data model relationships among customers, sales, contact activities, product inquiries, web registration, mobile inquiries, and so on. Each of these can be a table in a database. In the programming language, the methods or functions that assigns values, connects tables, and edits the database, and any behavior related to all these things are all part of customer class, abstractly defined as customer class. But when they get initiated by the process for each customer, for each behavior instantiation, each becomes an object that are reusable for each of the customers. Okay, for each of the customers. It is still somewhat abstract, but I hope it has given you some good information. Okay. I'll give you one more example before I ask you for your understanding. Before I go to the next one, actual application, actually that is already built into the system. See, in the CRM system that I talked about, it is something that we can create. But for example, within Python, the moment you talk about strings, that string class, then there are many methods that go with that results in objects for any specific given string. For example, length of an input string. which is a method, but under for a specific instantiation of a given string becomes an object. Is that clear, man? Again, for example, reversing the input string. That's again another method function that for a given string gets instantiated and it becomes an object. In the same way, uppercasing of characters for a given string, lowercasing of character for the given string, position of a string or a character or a numeric in a string, slicing of a string, joining of a string, justifying a string, splitting the string. All these things for a given string becomes objects of that string. So whenever I say the given string, that's where the instantiation happens. Is that clear, man? Is that clear, man? Thank you. All right. Any question there? It is still somewhat abstract, I understand, but I just want to make sure that we get across some of these very important concepts. At the same time, for example, I can use print function on the output of any of the above string manipulation. For example, if S1 is a string called "this is my test," then let's just go over this example with the actual Python IDLE. Okay. So let's say S1 is equal to this is my string. This is my string. That's okay. S1 dot find. See, I can apply the find function on the S1 string, and it requires a substring. Let me call it as my. Okay, it doesn't have to be my. It can be m also. So I want to know what is the find is about the position of the substring my in the given string S1. So the parent string is S1. The output, the application of find method on the S1, find is an object that I can apply. Okay, find is actually a class function, class method for string class. I can apply to the string S1. That's an instantiation for a specific substring called my. So when I do that, it gives me number 8. So what it says is that no, it starts with the position 8. So if we start here, remember the first position is always 0. It counts from 0. So you have to start T is 0, then H is 1, 2, 3, 4, 5, 6, 7, and 8. So the substring my starts with the position 8. Okay, are you with me? Okay, so note that this is a single. Okay, so here is one thing about functions or methods is that it will always be a parenthesis like this, simple parenthesis. Okay, simple parenthesis like this. That means it's a function. Okay, and the dot position tells us that we are applying we are applying the object orientation to the parent item. Yes, in this case S1. Okay. So more on loop. So again, remember that 8 itself is an object. I want to tell you that 8 itself is an object. Does that make sense? So there are things that I can do for 8 as an object. It's of course number, but it can be considered as a string also. Does that make sense? That's why I say everything is an object in Python. Okay, cool, very good. All right, so let's do a simple example here. Continue to do what is called, more on loops and conditionals. I want to touch on that. So let's take this example. Okay, I'm going to run this as a script. So let's see that, because it's easier for me instead of typing. C Python 3.4. Let's see whether it is test 3. Yeah, test 3. Okay. So same thing. It's I call it as a function, but the purpose of this is not just about showing you execution of function, but to show you if. Python has a very interesting conditional statement, if statement, and it has a else if. Sometimes some programming languages have else if, for example, SAS, but here in Python it is elif. Okay. So by using if, elif, else, I'm completing all possible mutually exclusive, totally exhaustive classes. Okay, and then I'm checking that with the -5, 3.401. For each time, it will go through this. When I call that function with -5, it goes through. It is less than 0. It puts it at equal to 0. Then when it is less than 0, it makes the x value to be 0, and then it prints it. That's the end of the story. Okay. So when I call next time at 3.4, it is not less than 0. It is not equal to 0. It's not 1. So it is coming out here. So it says print more. It prints just more. Okay, like that. So that's what it is. I just want to run this one. So I have to go to, that I have to go to, one moment, command line running here, CMD, and I have to go to the Python directory 3.434. Now I run it Python test3, right? test3.py. You see that the first number is -5, that's why it is negative change to 0. The second one is 3.4, that's why it is more. And third one is 0, actually, you can see that it's 0, so it is 0, it prints 0, and fourth one is 1, so it prints a single. So, but my main purpose is not just running this function, but to show you that how to apply if, not else if. Okay, are you with me? Let's go to another example. One moment. Okay, I want to talk to you about for loop. Okay, for loop, and then we'll talk about slicing, and then we'll do again for loop with a very interesting conclusion that the lists can be inserted and deleted, removed, and so on. Okay, list is mutable; it can change that's the main point. I want to prove it to you. And then I will also talk to you about range, and with the range I want to range and for if loops. I want to show you the importance of break, the power of break in the calculation of in the search for prime numbers. Okay, are you with me so far? And finally, I will talk to you finding even number and odd number. Okay. 26. Good, very good. So let's walk through that example. For loop. Okay, I'm going to use a for loop. So let me define this words, a list called words. List called words. Okay, it's here. I'm going to call it a different something else. Differentiate. I don't know, because I don't know what the other one means. So words as now these three. It's a list having 3 words. But the interesting thing here is that, remember, the words, if I say word 0, what do you think it will come out to be? If I put 0, it's this way. What do you think it will come out to be? Any idea? I think so. Let's see. Exactly. Okay. So the position of the list is always tightly mapped, uniquely aligned with the members. A very important point. Okay. So if I put W1, it should come window. Oh, why? There is no W1. It should be words 1, right? Sorry. All right. So so let's do this, and I can, I'm going to do like this, just to show you for loop in this. For W in words, what are we going to do? Let's do print within parentheses. Remember that, the new 3.4 version is above 3, it is always within, we have to use a parenthesis, W and length W. How about that? Okay. You see this one? So what it does is it just tells me the first word and its length, second word and its length, third word and its length, right? Now, okay, that's fine. Very simple application. Let's keep going. Now, next I want to talk to you about the slices, string slices. Okay. So let me explain something before I talk to you. Apply that in a small programming construct. So where we are doing it here, insertion and so on. So a slice syntax is handy to refer subparts of sequences, typically strings, and the slice S, that is the string start colon end, is the elements beginning at start and extending up to but not including the end point. Okay. So in this case, suppose we have S, the string to be hello. Hello, H refers to 0, E refers to 1. The position 1 of E is 1, position 2 of hello is L, position 3 of hello is L, position 4 of hello is O. And you can refer that starting from left to right or from right to left. If you start from left to right, it is increasing sequence starting from 0. But if you start from right to left, it starts from -1 and decreases. Are you with me? Okay. All right. Now, so this should make sense, right? Remember, when we say the string 1:4, 1 is included but not 4, right? So 1 is ELL, not 4 is included. Okay, that's why it is ELL. If I put 1 colon, that means start from 1 all the way to the end. That is LO. Does it make sense? On the other hand, if you put S colon, it means the whole, the entire word. Okay, entire word. But if I put 1:100, even though I have only 5 letters here, which means it cannot be more than 4 because starting 0, it doesn't make, it doesn't do anything, after 4 or anything. It's not that it will repeat or anything, okay? It just picks up whatever is left out, 1, 2, 4. Are you? Start is included, but end is not. Exactly, yes. I talked to you about, if you are going to pick up strings from the, if you are going to pick up string elements from the string S from the right to the left, then you use minus numbers. So here I am going to give you an example. If I provide just S of -1, then it is the last one. Okay, and S of -4, it is E, and S of -3 colon -3, then we are talking about colon -3 means this colon -3. So you are not including this, but you are including this. Okay, does this make sense? It's very important. Okay, but if I do S of -3 colon, then it is LLO. Why is that? S of -3 colon. That means it starts here and then goes all the way to the end. So that's why it is LLO. Does it make sense? Watch out this difference between these two. This is going up to, but not including the last 3 characters. That's what this means. But not including the last 3 characters. Up to, so up to, but not including the last 3 characters. That's what it means. Okay. So be a little bit careful about this and versus this. Okay. Right. I want a yes or no there. Very interesting things I'm going to tell you. It's funny. If you do S colon N plus S N colon, then it will be just the string S. Okay. Slices work with lists also, very important. That's what we are going to see next. Okay, slices just doesn't work only with strings, but also it works with lists. Very powerful, powerful attribute. Okay, so let's take this one, words again, and then for words in W. So what does this mean for words? For W in words, all. That's what this means. All strings. I mean all members of the words list, all members of the words list, you are going to do some collection of, execute some collection of statements. That's what this column means. This column means select all the members of the list words, but this column means you are going to do a collection of block of scripts. Okay, and what you are doing is that you are going to check for for W in words, you are going to calculate the length, and then when the length is greater than 6, asking a question, let's just check it out. Okay, so we already have that one, right? If I put this, what happens? Let's see. Okay, oh, not this, all of them. Okay, but I don't think so. If you put this, it will come out to be, let's say, you see error. Okay, it's not the same. Are you with me? Okay, so for it picks up only for those members of the words list which has length more than 6. You are inserting it at the 0th level. Okay, does it make sense? At the 0th member. That means, if you look at this one, in fact this is 6 but greater than 6, that means this is the one. In this situation I have differentiate but not defenestrate, but nonetheless it's more than 6 for me also. Because this is more than 6, that particular word, because for W, that particular word, for that member, the length is greater than 6, so I am inserting it at the 0th position. Does it make sense? Yes, of course, because for W in words, that's what for each word, for each member, don't even say words. Okay, of course this is words, but it can be any list, can be anything, right? For each member in words, but in this case for each word in words. Okay, so you can see the output is coming out to be, you inserted extra there, you increase the size of the list actually. Okay, so I mean, we don't have to run this one, we can see, but anyway, let's do it, why not? So we already have that words, so I'm going to say for W, let's just run it for W in words. So cat is moved to next position. Yeah, because it is inserting it, it is pushing everything else to the right. Okay, but remember, insertion can happen anywhere, right? We can check it out. How about we do here some tests? Okay, quickly for W in words, but the words I'm going to do all members of words. I made a slice here, really, right? Slice. We are going to do a execute block of sentences if, and that's also conditional, if the word, the member is length of that is greater than 6. Again, another block I'm going to do, insert words dot insert. Insert is an object instantiation for the already existing, for the object words. Okay, words is an object, and then you are instantiating with the insert based on some condition. And what is that instantiation? That is a function, insertion function, 0th position. You are putting that particular word, whatever that word is, okay, which is bigger than, more than 6 characters. Are you with me? So if I say it's already done, remember every line I execute, line by line I execute, it is done, right? So a word should have, you see, I can apply length also for words. Agree? It should be now more. I mean, it should be now 4, right? See? So what is it? So we can just check it out like this. So it pushed up the number of members increased. Yes, exactly. Length here refers number of members. Yeah, that's a beautiful point. the same function works differently depending upon what the position is, what the situation is, right? In this case, it's a list, but it can be anything else also. It can be string also. List is different from string, but still it works in the same way. That's the beauty of objects, okay? So what happened was I added, so instead of that, I could have done for W in words, I could have done this way too. Length can be used to find number of digits. Let's find out. Length. Okay. See, if I do like this, what happens is it will consider it as a string. Okay, it will consider it as a string. Let's see. Okay, it doesn't do, but let's do it this way though. If I do it this way, I make it as a string. Then it should, right? Oh, I thought it's what happened. Length. Oh, you know what the problem could be? I don't know. Try len. Yes, exactly. Exactly. Okay, because it converts it into a string and then it works with the string, not for the numbers otherwise. Okay. All right. So let's talk about quickly range. Range is a function. Remember that it's a function. It just says the function. But if I want to list that, then I have to do list this way. Okay. Does it make sense? That was the that's what I want to do. You see this one? So it becomes a list. Remember, list always the container outside containers has the shape square bracket. Now let's do this example. List also has list 5 comma 10 means it starts with 5, ends with doesn't include 10. Remember that. Yes, sequence of numbers. Yes. uh, that right number is not included. Okay, left number is included. Range is, and you can also do the by function by 3 steps. You move by 3 steps. Okay, are you with me? And also it can go negative numbers also. By negative, the jumps can be forward or backward. That's what this means. Jumps can be forward or backward. To iterate over the indices of a sequence, you can combine range and length as follows. Let's do this. Okay. Does that make sense to you? First of all, to iterate over the indices of a sequence, you can combine range and length as follows. Okay. Because you need to third parties for skipping. Yes, third parties for skipping in a range function. Yes. So let's do this one. Does this sentence make sense? To iterate over indices of a sequence, okay, you can combine range and length as follows. So let's see. So for I in range length a, because you know that length a is going to have what, 1 0 1 2 3 4, am I right? Or 5? Is it 5 or 4? Will it be 5 or 4? Let's just check it out. Okay, which one? I mean, length of a, what is it 5 or 4? Length should mean really the number there, nothing to do with 0, right? Yeah, it should be 5. It is 5. Okay. Now for I in range of length of a, so which is what, 1 2 3 4 5. For I in range 1 to 5, but remember when I put to 1 to 5, 5 is not included because it starts with 0. 0 means Mary, right? 1 means had, a means 2, 3, little means 3, lamb means 4. Are you with me? Print. No, I have to put colon, right? Print. Is this right? What I'm doing right now? What is wrong with this statement? Yes, exactly. So I should put this. Okay. And then one more return, it finishes the execution of the command. It's not just the command, it finishes the command, it even executes. So it did. Are you with me? So what have I done? What have I done? I've used range and length functions. I've used range and length function to do an iteration of something. The iteration here is printing. To do an iteration over a list. Does that make sense? I use range and length functions to do some iterative work on a list. But in this case, the iterative work is simple print, but it could be a very complex group of operations. Does it make sense? Okay. Len of len of a is used as limit. Len of a is used as a limit. Length of a is used as a limit. Yes, exactly. Right. Okay. All right. Loop statements. Here's the interesting thing. Loop statements may have an else class. Okay. It is executed when the loop terminates. When the loop terminates, here is an example. Okay. When the loop terminates, the else class is executed. But the termination may be because the if condition is satisfied, or maybe because a while condition is not satisfied, whatever it is, so whenever there is a the loop terminates through exhaustion of the list or when the condition becomes false. Either cases, an else class can be used uh, as an exit work. Okay, whenever a loop terminates through exhaustion of the list in a natural way, or when the condition becomes false with a while loop, for example, um, an else class may be executed. However, when you use a break statement, the else class will not be executed. In this case, you are going to see this example. Does it make sense? Whatever I said so far? Good. Okay, let's go through this. In this example, we are going to find whether a number between two numbers, what are the numbers between a range of numbers are prime numbers. That's what we are going to find out. Okay, so for n, for all the numbers in the range 2 to 10, that means 10 is not included, 2 is included, we are going to find out what are the numbers which are prime numbers. For x in range, so for each one of the n, we check whether something is the modulo divided by the members below that number. Okay, in other words, suppose you take a number 5 here, let's say 2 to 5. No, for n in 5, let's say, just randomly I picked up. For n in 5, you are going to check for each of the numbers between 2 to 5, 5 not included. Okay, 2 to 5, that means 2, 3, 4. You're going to check for each of those numbers. You're going to check whether the modulo of the division 5 divided by each of those numbers 2, 3, 4, 2, 3, 4, n is 5, remember. Okay, n is 5, 2, 3, 4 is the modulo equal to 0. If for any number it is equal to 0, we just print that number. Why that number? Because that number is a multiplication of two numbers, so it cannot be a prime number. And then if we get out of that loop, we go to all the way back to this n equal to 6. Does it make sense? And then you go through this for n equal to 6. In the case of n equal to 6, for each number 2 to 6, which means 2 to 5, you got to verify. For 2, you take 2, but n 6 modulo 2 is 0, so it is equal. So it is going to print, because 6 times 6 is 2 times 3, right? 3 times 2 or 2 times either way. Okay, so it will print that one. So it breaks, comes out now next, because once this is satisfied, we don't have to do anything else, right? Now come to 7. So what happens 7? For 7, you are checking for x. For n in 7, for n in 7, you are going to check for each of the numbers 2, 3, 4, 5, 6. And 7 modulo 2 is not 0. Okay? 7 modulus 2 is not 0, 7 modulus 3 is not 0. It is checking. So it is not, so it's coming back to this. Okay. 7 modulo 2 is not 0, 7 modulo 3 is not 0, 7 modulo 4 is not 0, 7 modulo 5 is not 0, 7 modulo 6 is not equal to 0. So if it is only equal to 0, it's going to come here and then break. Because it is not equal to 0, for everything, it worked out for every. So whenever it is not equal to 0, what is it doing? It is going back to this. Does that make sense? Does it make sense? Okay. So because of that, it finally it checked out all the things and then it came back here saying that no, loop fell through without finding a factor. So it says 7 is a prime number. And then you asked a question, break moves us to for n in range 2 to 10. Break moves once it is broken. I mean, in other words, it is not a prime number. It comes back and checks here. So the break is actually taking us back to this for loop, which means it goes to the next n. Okay. So far so good. You want to check this one? Just run it. Let's see what happens. So to make it easier, let's type this, and I have already typed this one. So let's see. I think it is called test 4. Let's see. Yeah, not this one. Sorry, not this one. Test 3. No, I don't know what happened. I'm going to let's type it. It's okay. All right. So what I'm going to do is this. I'll just type it. Okay. For n in range 2, comma. Should we do up to 100 numbers just for the fun of it? We will find all the prime numbers between 2 and 100. Is that okay? Yes. Yes? Did you say yes? I don't know. Did you say yes? Okay. So I have to put a colon here. And then for x in, sorry, x in range 2, comma, n. Again, colon. If n modulo x, remember in R, modulo is double percent. Okay. X equals 0, again colon, which means another block of sentences, which means another block of script. Okay, n comma, no, I should put this. Remember that n comma equals comma x comma star n double. You remember that it's single. That's why we made the mistake. You want the floor, right? Do you know why it should be floor? Is that right? Is that right? It should be a floor. Are you there? Yeah. It should be a floor, right? So let's see. And then break. Break. Else print n is n space is a prime number. Okay. One more enter. It's going to exit the whole function. Cool. But the problem is it repeated each number. Some of these numbers are repeated many times, and that is because we should have had a okay, now I'm going to copy that and then make a test file. Okay, that's better. You understand what I'm saying? So we need to have proper command. I'll tell you what is happening. So I'm going to type a new one. Okay. So what I was saying is, there must be a 2. You know why? There must be 2 here. Then it will come here. It won't come and repeat here. Okay, let's see. Control file save as. How about that? Python find prime.py. Cannot open the file, no such file. Python find prime. Yeah, just a moment. What happened? Oh, find prime, yeah, right? Find prime.txt. Isn't it right? What is the problem? Oh, you know why? Do you know why? You know why? Yeah, that's right. Else is placed correctly. Check your Word document. Where is the Word? Oh, Word document. Okay. Now there is some problem here. You remember we were looking into it before. Oh, it should not be here. It should be here. Is that what you're saying? Okay, let me go back to the file. No, that's okay. So this should be saved as. Okay. Let's try one more time. Still the problem is there. Okay, it printed all the things so many times, right? What is that you were saying? Well, we did something, right? When else print this, the output came out to be is a prime is a prime. That is repeating, getting repeated many times. Why? Because else, check else. Yeah. Uh, what was the logic? We went through this before. The logic is that maybe I didn't. Here it is better. Let's see. It's done better here. So else is aligned here. That's okay. I guess something wrong with the else. Yeah. But the question is, what is it? For n x in range, and you have to do that exactly, So I'm going to align it. For after n it comes okay, and then comes break. So it should be aligned with break. Okay, and then comes only. It it should be aligned with the for. Okay. All right. And then print should be aligned with colon. Okay. Let's try with this one. Okay. Now let's do it again. You missed colon. Oh, okay. Let me see. Which you mean? You mean not colon? You mean the apostrophe? I mean not apostrophe. The unquote. We don't need unquote here, right? Yes, right. What is that? Yes, right. Oh, sorry. Okay. So, what is that inconsistent use of the tabs and spaces in indentation? Oh, okay, okay. Uh, I should not be using tab. That's what he says. Okay. Because I use tabs and mixed and all. You see, it should not be the case. It should not be the case. Okay. Let's try one more time. Indentation error. Expected an indented block. Indented block. Oh, yes, yes, yes. Right? Understand? Yes. So the mistake was, I know this is a very important point I want to share with you. That is, we have to make sure that we cannot mix tab when you use the text editor. We cannot use mix the tabs and indentation. Character by character indentation. Always use character by character indentation. That's point one. Second one is this should be as part of the block of script to run after the colon, right? I don't. There is no other point, and this should come after the break. You mean to say we should use either tab or no. Just use the character by character move if you are using a text file. Character by character move, because it calculates characters and then moves. In the case of the shell, when we do the enter, it doesn't just go by tabs there. It goes by character. Okay, and 4 characters. With me? Okay. So cool. So let's keep going. I want to check one more program for you to do. That is handling exceptions. Okay. When used with loop, the else class has a more in common with the else class of a try statement than it does with the if statements. Okay. A try statement else clause runs with when no exception occurs. When no exception occurs, uh, a try statement's else clause runs when no exception occurs, and a loop's else clause runs when no break occurs. Okay. For more on the try statement exceptions, see handling exceptions. But for now, let's do this one. Okay. Application of continuous statement. So what does it do? For in numbers 2 to 10, it could be in any range. Take the number modulo 2 equal to, if it is 0, then it is an even number, and then continue. Print found a number. If it is modulo 2 is not equal to 0, what is happening? If modulo 2 is not equal to 0, you are just printing this found a number. That's all. Okay, does that make sense? But why is that we need a continuous statement here? Why do you think we need a continuous statement? Why do we need a continuous statement? The idea, remember, if this is true, it is going to execute this. We don't need to, we don't continue. So let's try without continuous statement. What happens? Okay, that's what I'm going to do. Okay, let's do that. No, continue is not same as break. Continue is just it's a passive statement. Break is you are breaking out of the process. Continue is a passive statement. So what does that mean is I'm going to tell you that it doesn't affect anything even if you don't have that statement. What is he saying? Let's see. What is he saying? Continuous statement. Does he do anywhere continuous here? Continue. Okay. The continuous statement also borrow from the continues with the next iteration of the loop. That's all. Okay. No, it doesn't go. Remember, print. This is part of the group of statement that is executed under the truth of this. That's all it does. So it goes to the. It is done. So it goes to the num equal to the next number. Does it make sense now? Continue. See, continue is part of the truth statement execution of this. Continue is part of the truth statement. So in fact, if you don't have continue, also it should work. That's my point. Okay. Can you check it out yourself? I don't need to do that. And then let it be a homework. Okay. Let it be a homework. Let's keep going. While true. And there is also past statement. I'm going to leave those things. And then define functions. We did this before. Okay. I'm going to basically stop here. More on defining functions. We will talk about keyword arguments in the next section. Okay. Thank you. Bye, everyone. Stop.